Thank you, everybody, for coming to another one of our PERG EWI Coffee Break series. This is geared towards our EWI candidates, of course, but we are happy to have all of our membership and anyone from our membership here and attending. Today, we are talking about portable power and the job of the rigging electric crew. So thank you all for joining us, and I hope we will give you some valuable information today. And of course, I cannot go further into this without thanking our annual sponsors, without whom none of this would be possible. Um, we have Applied Entertainment, ARI, Astera, NFP, Lightgear, Panavision, and Taylor supporting us for 2025. So thank you to them for allowing us to give you all this great programming. And today we're going to hear from two presenters, Jim Mitchell, whose credits as Assistant Chief Lighting Technician, or Best Boy, include Ted, American Hustle, The Equalizer, and most recently, season 2 of Walking Dead, Dead City. He works frequently as a rigging electric best boy as well, and his credits there include Little Women, Don't Look Up, Spirited, and Madam Web. Originally from Pittsburgh, film school at BU brought him to Boston, where he has been a member of Local 481 for 29 years. So we're very lucky to have him here with us today. And we will also hear from Harry Box, who is the author of The Set Lighting Technician's Handbook. This book has served as a training manual and reference for lighting technicians for 32 years. Harry was a lighting technician himself, rigger, and gaffer in Los Angeles, and he later became a camera operator. He's now the manager of PERG and continues to write about technology and safety for the industry. So thank you both for hopping in today and giving us this great presentation.
Great. Well, I will just give you a quick overview of what we have planned today. I'm going to show some of Jim's rigging photos and some photos that I have. We're going to give a rundown on what a portable power system does and how power and data are delivered. And after that, we're going to have some questions I'm going to have to ask some questions of Jim about the responsibilities in the life of, in the world of electrical rigging. And I hope you will join me in asking questions as well. Before I start, let's see if I can see everybody here. Let me stop sharing. Not very many people have their cameras on, so turn your cameras on. Let's just take a quick poll here, just to raise your hands if you are actually a lighting technician already. And okay, we've got a couple, AGR. And so some people have done some lighting. How many of you are interested in learning more about lighting as a possible career? We have some, where are our EWI candidates? Where are you guys?
They're all hiding between different names. If they're even here, I know they're supposed to be here.
All right. All right. Well, how many people here know what a three-phase power system is? Raise your hand. Okay. That's you. All right. And good, Jim does. That's excellent. So, all right. Well, let me look at let me show some slides then, and we'll get on with this here. We can see what some real rigging looks like. So, most of you might think when you say rigging, you might think of something like this: big soundstage, catwalks, lots of lights hanging from above, truss, pipe, banks of lights. You got power up high, you've got drops all around the set. This is your typical soundstage kind of situation. And I'll just point out while we're here that you can see there's a little light in the bottom right hand corner of that set and shining on a power box, and that is what this is all about. And you'll also notice that there are no cables anywhere else. And that is also what it's all about, right? So it's about creating utility for the crew without creating any kind of a mess or a hazard. Um, Rigging can look like a lot of things, and this is a real common thing, right? Blue screens. Um, Again, lots of lights, no cable visible. Rigging can also look like this on location. Very often, it's it's a condor or a telehandler, or maybe even a crane that's rigged up with some lights, like for a night shoot. So this is one of Jim's. What was this? What was this, Jim?
Uh, Hi, I'm Jim. Thanks for having me. This is a telehandler called a Magni, which is a really beefy forklift basically that can reach up and out very far, and then it can turn once it's in the air. So the lights there are 16 Vortex V8s, and then two theatrical moving lights hanging off of the bottom. I'm not sure which moving lights those are, but one of the great things about the Vortex V8 is that it's IP rated for rain. So we can rig that, put it on the lift, and not worry about weather. So these moving lights, I'm sure, are also IP rated. So this could work in any weather and rig it on a Thursday. Maybe they use it for a week. You know, it doesn't, the shooting crew doesn't have to cover it every night. Like it's a huge benefit to have waterproof equipment.
Yeah, yeah. Here's another picture of it in the backs of the vortexes.
And as you could see from the previous photo, since it's a LED, it can work at night. It can work for day. It could be a daylight source. It could be a warm source. You can change colors. You can do lots of things with it that you couldn't do with traditional tungsten or HMI lifts.
And here's another possible scenario for rigging, which is this must be a daylight scene, I'm assuming.
Yep, that was a big daylight scene on Madam Web where they needed a long throw from a distance to cover. I think it was like a like a some kind of a crowd scene traffic accident or something. So they needed to be able to reach from far away. And then of course
So
when the
that's
camera,
giving it like a hard edge on.
yep, giving a hard edge on a big group of people, which is typically from the back. So then when the camera looks the other direction, you need to drive this lift to the other side and backlight them from the other side.
And so yeah, and this is a ridiculous number of Amaxes in in my humble opinion.
Yeah, it's a very bright source for
Yeah.
sure.
Yeah, so it could also look like this. This is like a big soft light, right? This is light gear product.
Yep, that's a light gear. That's the light gear.
Light
The
tile.
the light tile. The name was escaped me for a second, but those are super lightweight, and you can put them in a lot of places pretty easily. They are
Yeah.
not waterproof, however. As you can see, there's you can kind of see from the picture, there's some visqueen, some black plastic over the
Yeah.
top,
Mhm.
but they definitely require a little bit more attention trying to keep them dry if the rig is, you know, for more than a couple days.
Yeah. All right. Really good point. So here's the kind of what that kind of big overhead soft light would do. Gives you like an ambient level, covers a big area, and it's out of the way. Um, it's usually either a backlight or a top light like this. But rigging can also look like a lot of things. And here's an example of a vehicle. Obviously, everything has to be self-contained. Basically, everything's on top of the vehicle. In this case, sometimes you have a trailer, and the rigging is all, and you got lights shining in from all sides. Um, you got situations like the one on the left is sort of it's a common situation where you're in a beautiful old building. Maybe it's a period movie, or maybe it's just the setting is really regal, and the location is extremely sensitive, and the rigging has to be done very, very carefully, and you don't want to mess anything up while you're doing it. Um, The example on the right is more like a lot of what you see these days is LED ribbon. These are LED fixtures, but it's like a custom set of fixtures, and fixtures is sort of a subcategory of rigging. These could be 5-color LEDs. They could be bicolor. They could be just one color. But a rig like this little passageway could be, you know, universes of channels to control that. Another example of dealing with a location without putting too many stands on the ground.
Right, and the balloons, of course, are helpful if you can't put truss, if you can't hang anything, you can float the balloon and maybe it gently rubs the ceiling. So we'll use those in a lot of locations, like churches and museums or places that aren't going to have rigging points, but you want to get a soft source up overhead. And the little ropes, the little strings that you can see, you can usually dress out, keep out of the shot, or if they have to be in the shot, they can digitally remove them.
This is an example where the DP wanted to recreate this ambient light from an Alaskan sky. And so they got a photo, a high-res photo from Alaska, and they pixel mapped the exact colors and then pixel mapped it onto this, like, I don't know how many hundred sky panels. And then they softened the whole thing, and then the result is like this unique blend of colors. So that gets into a lot of control, which we're gonna now get you. So in order to do all this, we got to have a portable power distribution system. And I'm just gonna try and get through the nuts and bolts of a portable power distribution system without too much pain. Stop me if you have questions. Feel free to just speak up. Or Allison, if someone puts something in the chat, could you just let me know? Because I'm not looking at that. All right, let's just talk about like what you have to accommodate with if you're designing a portable power distribution system. What do you have to accommodate? Well, first thing you have to know all the different kinds of loads that you might need to use. And so starting off with this tons of different things that are 120 volt loads that are less than 20 amps. Usually have an Edison plug on it like this. There's a few different other plugs that could be. But this is everything. This is everybody's phone chargers, battery chargers, optosplitters, all these kinds of lights, smaller lights, the honey wagon, right? Like the trailers, everything's, most of those things are 20 amps or less. The next thing you could end up with is something that's more than 20 amps. So like 4K, 5K, 6K, 9K lights, Area 12, T12, could be a 120 volt light that requires a much bigger connector. So you got to accommodate that. Then you've got 208 volt single phase loads, like the larger HMIs, the Area Max, the 20K tungsten lights, just to give a couple of examples. And a lot of the HMI ballasts are 120 or 208, or they could be both. And then there's another type of load, which is less common, but is still out there. And that is a 3-phase load, a 208 volt 3-phase load. So this is like motors are the thing that is always 3-phase, or commonly 3-phase. Also heaters, air conditioners have compressors in them. It's also motors. Water pumps are also motors. So anything that's got to have a big turning force is often a 3-phase load. And we're going to look at in a second at what that really means. The last thing you might have is a 480 volt AC 3-phase load, which air conditioners are commonly, big air conditioners are. And this soft sun unit, this 100 kilowatt soft sun unit. Now you could run this soft sun at a lower voltage, but the biggest cable that's portable is 4-aught cable. You call it portable because it's 100 pounds, which is just barely portable. But if this was not 480, if this was anything less than that, you would have to have a bigger cable than that, which would not be portable. So those are the kinds of loads. And So the basic requirements for a portable power distribution system are to accommodate all those kinds of loads, every one of them, and meet the requirements of the NEC. And there's a lot of requirements for the NEC, but the two that are relevant to portable power distribution systems are overcurrent protection wherever there's a reduction in wire size, and equipment grounding, continuous equipment grounding from the power source all the way to the load, right? So this is what is accomplished by a portable power distribution. So those two things uh, um, are the main things that are accomplished by a portable power distribution system. So we start at the generator, bunch of cam lock connectors on a generator, 5 wires coming out of there. The 5 wires are ground, neutral, phase A, phase B, and phase C. We carry that current to the set by feeder cables. We use EISL cables, tenement energy exchange lighted cables that's a lighter weight jacket, believe it or not, than other kinds of cables. So it's lightweight, it's flexible, it's amperage rating per the National Electrical Code is shown here. So a 4-aught cable, which is a big single conductor cable like that, 360 amps. 2-aught cable, which is smaller, sort of 1/2 inch, 3/4 inch, 265 amps, and banded cable, which is 5 cables banded together with tape, is 170 amps each phase. So on a 3-phase system, we have phase A, phase B, and phase C. The 4-aught, we'd have more than 1,000 amps available to us at the destination. So we get to the set, and this is a very complicated set, but the feeder cables are going to terminate at these 2 boxes at the bottom center of the picture are spider boxes. It could also feed, this is an older picture, so there's a lot of dimmers, racks in the background. There's also a GFI unit, this giant thing on the left. And there's 2 transformers on the far left and right side of the screen, which are actually 480, 208 transformers. That's kind of a big rigging thing that you don't run into very often. But the point is that the cables terminate into, well, they run through a spider box. So this is a splicing block. There's no overcurrent protection. There's supposed to be no reduction in cable size at this point, unless you're plugging in a load. Like if you could plug a 12K into here or an 18K into here, if it's got cam lock connectors on it. So it's a splicing block. There's no overcurrent protection. You can put 4-aught, 2-aught, and banded. It allows you to split the distribution off around the set in different directions. You'll notice that there are 2 neutrals and red, black, and blue. And we will not talk about why there are 2 neutrals until someone asks a question about it, because that is like what I would call a rabbit hole. All right, so let's see how you get all these different power things from a 5-wire system. So you've got these 5 wires, right? Ground, neutral, phase A, phase B, phase C. So what that really is 3 120-volt circuits. Phase A to neutral gives you 1 120-volt circuit. Phase B to neutral gives you a second 120-volt circuit. So that's another 360 amps worth of 120 volts. Phase C gives you another 120-volt circuit. So it's 3 circuits of 120 volts by connecting any of the phases to neutral, connecting the load between any phase and neutral. So you can also get 3 208-volt circuits by connecting any phase to any other phase. So phase A to B gives you 208 volts. Phase A to C gives you 208 volts. Phase B to C gives you 208 volts, right? So that's 2. We got 108 and 120, and we got 208. We also can get 3-phase. This is from the motors, right? Like by connecting just between the phases, no neutral. And notice that there's always a ground. So in order to make this magic happen, we have distribution boxes. And distribution boxes are where the feeders terminate. They terminate into these cam lock connectors along the bottom, right? There's your 5 wires. And you'll notice if you look along the top, there's color coding red, blue, and black to tell you that these 100 amp connectors are connected between neutral and red, blue, or black. So this is where you have your first reduction in cable size. Now we're stepping down from 4-aught cables down to just 100 amp cables, which are number 10 cable. And that would be, so you have these circuit breakers, 100 amp circuit breakers next to each one of these outlets. This particular box also has these test jacks in the left corner. Test jacks allow you to plug a voltage meter or a multimeter into the system at this point. It tells you what your voltage is. Tells you if your frequency is on target. Sometimes if a generator gets out of whack, the frequency will be off. And sometimes if you have a very, very long cable runner, if there's a problem, you could have a low voltage at the loads. So that's what that's for. All right. So then flipping that box around, there are 3 yellow outlets. So yellow is kind of an unofficial color code for 208 or 240, something in the upper range of voltage. And you'll notice that each one of these connectors has a circuit breaker. The circuit breaker is a double gang circuit breaker. So if we're plugging a 18K into this, let's say that's 96 amps per phase, this would be taking, this one on the left would be taking 96 amps from blue and 96 amps from black. It's dividing the load between those 2 phases. And then on the very right side, you see there's a bunch of courtesy outlets. That would be for having a light that can illuminate this thing in the dark stage or at nighttime, or for phone chargers, right? What do these get used for, Jim?
Phone chargers, video monitors. Sometimes the props department needs a hair dryer to blow hot air on some glue they're trying to dry or something. I was going to point out, in addition to the yellow coating on these receptacles, if you could flip the box around, you can see that the spacing is different on the plugs. On the 120 version, the hot and the neutral are the neutral and the ground are closer together, and the hot is set aside. Whereas on the yellow one, they're spaced a little differently, so you can't accidentally take a 120 cable and plug it into a 220 cable, which could be exciting for all the wrong reasons.
All right, so there are a variety of boxes. This is a 600 amp box, so it's just half the size. It still has 5 wires, but not half as many outlets on each one. This is a 400 amp box, which is only uses 2 of the phases. So you could have a 3-phase system and just use 2 of them on this box, or you could have what's called a split phase system, which is another rabbit hole that I won't go into unless someone asks me to. But we might talk about it a little bit, in another slide or 2. There's tons of adapters and splitters. I didn't have enough pictures of adapters and splitters. There's no end of how do I get from this to that, right? Like, so here we're showing 100 amp shapes pin outlets connected to cams, or a 240 stage pin outlet connected to cams, or a cam splitter. But there's, basically there's all these different connectors, and there's always an adapter to get from one to the other. So the best boy is saddled with this job of making sure that he knows what everything is needing. Oh yeah, so there's an example of a 120/240 system. I was saying a split phase system. So in this system, the generator actually only produces 2 phase wires, neutral and ground, and the voltage is, instead of 208, it's 240. And some gaffers believe that the voltage helps the performance of HMI ballasts. This was kind of a bigger problem at one stage in the evolution of ballasts than it is now, but it's also much easier to balance loads when you only have 2 phases to balance them between, because anything that's 240 is automatically balanced. But I won't say any more about that unless anyone has questions about it. Yeah, here's the whole family of Bates connectors. I think these days, really the 2 on the right, the 100 amp and the 100 amp 240. Maybe to some extent 60s, you would need splitters for 60s for 5Ks and 6Ks kinds of lights, but And maybe if you were working in a venue and they had theatrical lights with the 20 amp stage pin, but I've never seen a 30 amp stage pin, I don't think, in my life. So that gets us to the outlet box. And so once again, we're reducing cable size. We're dropping down from the 100 amp down to the stingers. So we have to have overcurrent protection. I got a tickle in my throat here. I may have to get a glass of water. But yeah, so, and this is just one. As I say, there are many different kinds of outlets. You could have twist lock. You get a power con for movers. You might have socket pecs. So there are a few different kinds of boxes like this going from 100 amp, but basically it's 5 circuits, duplex circuits, and that's your final destination. So that's the power part of it. Now, really quickly, if I can, we'll just do the lighting control part of it. So these days, this guy is the man behind the curtain and does a lot of the work. Lighting technicians bring in the lights, hang them, and then this guy is the one who's in charge of getting the level and setting the color and the rest of it. So real quick, a traditional DMX system was set up as like a daisy chain kind of system like this, where you have a console, the control cable, which is a 5-pin XLR cable, runs to a dimmer pack. It runs out of another connector on the dimmer pack and into the next pack and just daisy chain together. And on the last one, you have a terminator.
And the dimmer packs, basically that is a tungsten system. That's where you're using mostly incandescent fixtures, so everything's going back to a dimmer pack. And at the console, he's lowering the voltage channel by channel to change the intensity of the lights. We're not using as much tungsten. Sometimes there'll be call for an incandescent or a tungsten set, but often today most things are LED, so we're not using as many dimmer packs as we used to.
And we were limited here to 512 slots, and a slot is a channel of control. So if a dimmer has to be run up to 100%, that's one channel of control. But if you've got a light that's got 5 LEDs in it and you're doing RGBW, that's automatically 5 channels of control. So we're going to get into this a little bit more in a second, but let's just talk more about how we do the DMX runs. We're more likely to do it this way because, well, why, Jim? I think you can explain this better. Why we don't want to do daisy chaining?
Well, so basically, let's say on those top 3 lights on the screen, if those are daisy chained together, that would mean that DMX was going into and out of 1, 2, and 3. So if you had to take down light 2 or move light 2, then if you're moving it 20 feet in the other direction, then you have to run DMX to it and then back to maintain the chain. I'm pointing, like anybody can see what I'm pointing at, but basically by doing, in this picture, he's doing home runs of DMX back to the splitter. That way, as you move the light, you're just moving its own home run. You're moving it. It has to have power run to it and data run to it. So if you're not daisy chaining it, you have a little bit more flexibility to move it around.
Right. So so here we've got like 2 universes coming out of the console, and going into an optical splitter, which is just a way of splitting that control signal, and it regenerates the control signal. So it's something we like. The rigging gaffers tend to like to put in optical splitters because if you have a very long run, or if there's anything, it cuts down on possible ways that the signal could get interfered with. All right. So data and power start getting combined. And we end up with boxes like this where Now, every light needs power, but it also needs a DMX signal. So we're combining an optical splitter basically in a box, right? So the DMX goes in to the optical splitter, the 100 amp power comes to the box. The box actually also powers up the optical splitter. And then you might end up with something like this, which I guess was popular for a while. Jim said it's not so popular anymore, but it's a super stinger, right? So you're running data and power. It's a stinger that's just running data and power to each light.
Right. So just running one cord instead of two cords to a light. I mean, more of the lights are becoming wireless. So often we will use them wirelessly, but sometimes due to bandwidth issues, the programmer wants you to hardwire it. So you always need to have DMX on hand, even when you are working wirelessly as a backup.
So speaking of wireless, the box on the right here is a optical splitter, but it's also a transmitter. So it's transmitting one universe of DMX via CRMX. CRMX is one of the wireless protocols. And Zena, you can correct me if I'm getting this stuff wrong here. Here's the everybody has one of these on set, right? Like this is a Centella kit. It's got a wireless controller with a transmitter on it. It's got a bunch of receivers which go on all of the lights. And now you can control all of your DMX just radio signals. Basically, it's all CRMX.
And a lot of lights come with CRMX protocol built into the fixtures. So you
Yeah.
don't even need a receiver on a lot of stuff these days.
Yeah. If you go to the Lumen Radio website, you can see what the chips look like. It's just a little chip, like they put in a light, and then it can do this. So let's talk real quick about protocols. So fixtures can use different protocols depending on how much control. So the fixture can be designed so that you can control it with just 5 channels, or if you want a whole tonnage control over it, you need to do a lot of tricks, then you're going to need more channels. So let's look at an example. Here's these Vortex 8s, right? There's 37 different possible protocols that you could use, and you have to pick one as the rigging gaffer. I guess or maybe it's Jim who picks it. Maybe the programmer.
I guess it's a conversation between the programmer and the chief lighting technician about what effect they're looking for, how much control they need. I mean, spoiler alert, they usually want all the control. So, in a lot of cases, those 16 lights could all be on the same channel because it's a moonlight, but we're still going to address them separately so they could put different spots in the moon if they wanted to or whatever.
So this could be as small as 80 channels, like the 16 light rig we're looking at could be as small as 80 channels if there's 5 channels per light. That would be easily to fit into one universe. In fact, you could fit 4 of them into one universe. But it could be, if you went into pixel mode, 2080 channels, or 5 universes, just over 4 universes of channels that you would spend on this one thing that you would require for this one thing. So we give a better idea of what this means. Like here's a light, a vortex that if you're controlling it this way with CCT and hue and saturation on an 8-bit, so 8 bits has to do with the resolution, right? Like so here we're like designating one channel to do hue, for example. If we did a 16-bit version of the same protocol, then we could have 2 channels designated what the hue is, and we would be able to refine the hue just that much closer. But with this 8-bit, we only have 8 channels, so that's kind of minimal. And you can see here that each channel has a particular role, and you'd it's 8 slots per fixture, so the DMX addresses for the fixtures would be like if the first fixture was set up as 1, the second fixture would be set up as 9, the third fixture would be set up as 17, and when it sees its DMX address, it will respond to the following 8 channels that it receives. So that's how that works. Now it gets one level more complicated when we get Ethernet. So, you know, DMX is a very simple system. It was really designed for dimmers, for running one channel up and down. They thought 512 channels was going to be more than enough to do any theater. But you can see when you've got 130 channels in one light that doesn't go very far. What you need is a more sophisticated system. And what we ended up deciding on was Ethernet, which is, it's internet protocol. It is what your computer uses. And you can have something like 64,000 universes on Ethernet. So that increases the speed. It increases there's error checking. There's tons of things that computers do that they have to do that a DMX just doesn't even think about doing, right? DMX is very simple. It's just like, here's my channel. Here's the value I'm assigned to. Here's the next channel. Here's the value. That's it. With a computer protocol, you have a lot more control, and you can do a lot more things. You can have two-way communication. So, so here we have an Ethernet port going in, and looks like 8 DMX ports coming out. And depending on how this particular node is designed, it may be that you can assign each of those ports to a different universe, or that all those ports are for a single universe. It's basically an optical splitter plus a node. So looking at a diagram of how an Ethernet system would be set up, now you have a console that's producing Ethernet. It's not producing DMX. It's producing so if you think of Ethernet as like we're talking over the phone, and SACN, or the protocol that's being used, is like we're speaking English while we're talking over the phone, right? Like SACN is one of the protocols you could be speaking to talk from the console to the lights. There's other ones, ArtNet, and then there's proprietary protocols, HogNet, and I think all the console manufacturers have proprietary ones. And then, so the parts of an Ethernet network are just the same as the parts of an Ethernet network at your home. You've got a switch. A switch has just got it's got RJ45 connectors in it. Just those things that look like an old-fashioned, a giant old-fashioned phone connector. And all that is to connect the network together. And the switch communicates the signal to the IP address that it's directed to. So you can have consoles, you can have servers, you can have nodes all connected to the same network using a switch. Then we have these nodes, which we just saw a node. That was a node. Where this is the Ethernet signal coming in, and it's changing it to DMX and sending it out as it's originating DMX. It's creating a DMX link. And as you can see here, these outputs can be assigned. So you could have this on universe 1, this on universe 4, this on universe 2, this on universe 3. Does that make sense? All right, we're getting to the end of this little presentation here, and then we'll get to the fun part. So here's what it sort of looks like on set, where you have power, and then you've got sort of the Ethernet transition, right? So you see the orange and the green tape. Those are marking the network switches. So those are Ethernet in and out. And then the thing above that, in the Furman box in the middle, the thing above that is a node. So it's converting Ethernet to a bunch of DMX outputs. DMX outputs are going to these 4 DMX optosplitters that are sitting on top. And I don't know if you can see it, but they're actually labeled universe 1, universe 2, universe 3, and universe 8. And people like assigning colors to universes makes it a lot easier. So you'll notice that the tape colors are also going to tell you what universe you're with. So this is a bit of a mess. And this is the cleaned up version. This is the better version than what was preceded it. But it can get cleaned up even more by going to something like this. This is the Rat Pack Unity box, which is all these things in one. So it's an Ethernet switch. This is where Xenia, you can really help me if I'm wrong. But this part over here, the upper left-hand corner, you've got the Ethernet switch, right? So you can bring your Ethernet from the console, plug it in here, and then plug out any other parts of the network you want to into here and continue your communications. It's also a DMX node, so it's converting Ethernet into DMX, and you can assign those outputs. So again, you could have outputs that are universe 1, other outputs that are universe 2, and so on. They could be assigned. This is you've got optically isolated DMX outputs, so that's like an optosplitter. It's got power down here. It's got 2 universes of CRMX, so now you can transmit or receive a wireless signal either using the Ethernet that was fed in on hardwire or received wirelessly. And you can have, and then now we're talking like this is no longer just a box with lugs inside it. We're now talking about something that needs a firmware update. All right, so just a couple more slides. Just looking at wireless systems real quick. Like this is a simple system like you might have for a commercial where you just have a Rat Pack AKS Plus and it's transmitting CRMX to all these other devices. The connection to the iPad is just via Wi-Fi. So that's, you know, like a one-person setup, the gaffer walking around the set with an iPad in their hand. And then here we've got Aries Skylink. The advantage of Skylink is that it's CRMX with RDM. So RDM is a way that the fixtures can talk back to the programmer in the nicest possible way. They can, you can assign if I'm correct about this, tell me if I'm wrong, Jim, you can assign the start address of a fixture using RDM, I believe.
Yeah, which comes in handy when they're up in a rig where they're hard to reach. When the programmer can make changes from the desk, that's huge.
And it'll also give you like an error signal if it overheats or something. It'll give you some feedback. So that's RDM. And then here's like, you know, if you were going entirely wireless, this is what you could end up with. So here you've got down on the bottom, you've got a lighting console sending out Ethernet to an unmanaged switch. The switch is directing hardwired signals to 4 AKS units, which are transmitting CRMX on different universes to 4 different universes, to 4 different functions on the set. So,
and you know, some of the lights we're using are battery operated lights now. So when the light can be wireless for power and for data, it's a huge advantage that you can bring it in really quickly. You're not limited by where you can put it. There's not wires to dress. You have to worry about actors or the wire going under the dolly track. So the wirelessness of power and signal is a huge benefit.
so that's the end of my presentation. You'll be happy to hear. So I just thought I got some questions for Jim. We can have a little discussion about the life of a best boy and a rigging person. So tell us a little bit about the responsibilities of a best boy.
So basically, the hierarchy in the electric department, the chief lighting technician and the rigging chief lighting technician are the heads of the electric and the rigging electric department, and both of those positions have an assistant. some people still call it a best boy. Some people are trying not to use that term anymore. But so the assistant is basically in charge of everything that the gaffer doesn't need to deal with. So the hiring, the staffing, keeping track of the schedule, how many people do we need on Tuesday as opposed to how many people do we need on Wednesday, the equipment ordering, putting through the payroll for the people, purchasing, keeping the expendables on the truck stocked, communicating with production, tracking down when somebody's paycheck didn't show up, tracking that down, with accounting, talking to transportation about making sure you have the right amount of trucks and big enough trucks for what you need to move on a particular day. Dealing with locations. Is there room to park the trucks? Where do we put the lifts at the end of the night? And where do we put them after they're rigged? So it's a lot of communication with a lot of different departments. And by the best boy doing that, the gaffer, the person in charge of the lighting, or it doesn't have to deal with that stuff. They can focus on what's important to them.
So speaking of that, what tell us about your bosses? What are they focused on?
Well, the gaffer is focused on what the DP wants, and the rigging gaffer is focused on what the gaffer wants. So it's just kind of like, how many bosses do I have? It's like a really big number, because if I'm on the rigging side, if the set gaffer asks me to do something, I have to do that. We're also working for the DP. We're also working for the unit production manager. So there's a lot of people above us for sure that you have to try to keep happy. But the rigging gaffer really wants to have power in all the right places, so that when the shooting crew shows up, everything they want to turn on can be turned on, and you're prepared for the eventuality of the camera spinning around and not seeing all of your equipment. So you're placing your equipment in the right place, and you have power in all the places that it's needed. And there are other departments that need power too. Sometimes special effects needs a power run. So for some big fans, so that should be on a separate generator, because you don't want the draw of the fans to interfere with the voltage that the HMIs are trying to get. Sometimes you're dealing with power for the star trailers, and I mean, there's almost every department needs power. So doing this job is a good way to meet people from every department. Some jobs you don't interact. The makeup person doesn't really interact with every department. They interact with the actors, but in electric, everybody wants something from us at the end of the day, it seems like.
That's great.
I have a question for Jim.
Yeah.
Well, first I have a comment. I have always thought that rigging gaffers were power hungry.
It's a good one.
Not entirely related to what you're talking about, but what do you think about battery power, about power stations, and have you been implementing that over diesel generators much?
That hasn't really come up that much for us yet, because I suppose it would be on a case-by-case basis, but I haven't seen a battery yet that can run like a big HMI load for a number of hours. I know on a job a couple of years ago, they put in some big battery packs for base camp just to run the star trailers and the campers. But I think ironically, they were also being trickle charged all the time off of a tie-in. So it was kind of like we're still doing a tie-in to this big battery. We've used some Yetis, some Yeti 3000s have become common for us, because that's just a quick way to get power to one light or power to a video monitor. That it's kind of like on a little dolly, weighs about 50 pounds. You can sort of just roll it up to wherever you need it. But we haven't really started using big battery packs for set power yet.
Seems like there's a few different products coming to market that are aimed at that, portability, being able to put a light out anywhere, or just power up a trailer or something that is it's portable. It's not big. Doesn't require a forklift.
there's almost always an email from someone at the studio before a job starts about what are we going to do to be more green, and they suggest a few products, and we politely say that isn't really big enough or dependable enough for what we're going to do. Like some of these battery packs, you would need more trucking, you'd need to hire more drivers, they wouldn't last the whole day. They tell, and there's a lot of I have to be polite about what I say, but I try to be as green as possible. But sometimes, the amount of waste that we're using in the industry, and the amount of lumber and plastic that's going just from construction that's going into dumpsters is terrible. But they give us water bottles with the name of the movie on it and think they've taken care of their green responsibilities. So it's definitely tricky. I would like to see more batteries, but I just don't think they're there yet.
Have you seen like the I think it's like Sunbelt rents, the like 90 kilowatt hour, basically like they're the size of a tow plant. And I know like Netflix uses those. But yeah, there's tons of holes in the efficiency of it with, them having to charge that somehow and all these things. But
yeah, the job they were using it in base camp was a Netflix job, so maybe that was Sunbelt. I was only part-time there, so I don't know exactly what they were doing with that.
It's it's a tricky thing because at the end of the day, a battery is not a power source. It is a storage device, and so you got to get the power still from somewhere else. So the efficiency is only in, if you're getting it from a generator, it's only in running the generator more efficiently. Or if you're getting it from shore power, then that has to be an efficient, it's efficient because you're getting it overnight, maybe. So it's like, we're yet to see exactly how the workflow and the right kind of equipment to suit our needs.
And weather. I drive an electric car, and I know in New England in the winter, my electric car doesn't go as far as it goes in the summer. That there's energy loss, keeping the battery warm enough, keeping the battery conditioned. Working on sets here, I could see that the weather being an issue on batteries replacing generators.
So tell us a little bit about how you learned the craft early on. Like, how did you acquire the skills that you have made you successful?
Well, I went to film school, which I definitely didn't have to do this job, and I had a pretty small cohort at school, and everybody volunteers to help on everybody's projects, and it just becomes you definitely can get pigeonholed as you help out on Bill's project, and then when Bob has a project, he's like, hey, who did sound on the last project? That guy should do sound again. This guy should do lighting again. That guy, the dolly didn't roll off the track. Let's use him on dolly again. So as a student, I just started doing a lot of lighting on other people's films, and met some professionals in the Boston area, and then just started freelancing with them after school. So I kind of did it backwards. I kind of started out as a gaffer on tiny things. I learned about exposure and learned about the photography end of it before I really knew about rigging or a lot of the equipment that I use today.
And then how do you end up learning about that stuff? Just hanging out on set?
Just getting on set and just listening. And I know I've definitely worked with people who came up through rental, who started out at rental houses and ended up wanting something more and wanting to be on set. But yeah, just starting out in rigging, it's really hard to start on shooting because of the pace of the shooting crew, and there's not really time to ask a lot of questions during a setup, and people are kind of running around with their hair on fire on set. But on rigging, there's typically a more controlled pace. You know what you have to do, how many hours you have to do it. You have sort of more clearly defined goals. And on the shooting crew, you're more subject to the whims of the director or the actors or the weather. The sun goes behind a cloud or it starts to rain. We have to drag a bunch of lights off the truck. It's getting dark. We need to light this up because we're running out of daylight. So rigging is a more relaxed pace where you can take time to learn what the equipment does, and there's a little bit more time for teaching there for sure.
Yeah. Yeah. So let's talk about the rental company's role in this, because you know, how does a rental company help you succeed, and what might they do that is not so helpful?
Well, we typically on a big job we'll have a 40-foot trailer full of equipment that we have, you know, for the whole 12-16 week show. So we have that gear, but then the plans will dictate that different sets have different needs. So one set might need a bunch of HMIs, another set might need a bunch of extra cable because then we have to run cable over a bridge. So those drop packages, that's where I spend most of my time at the rental house. Is while the crew is out rigging sets, I'm back at the shop picking up more stuff for tomorrow's set. So I like to tell people I'm working on tomorrow and I'm working on yesterday. I'm not often working on what's happening on set that day.
Right.
Because I'll bump into somebody and they'll be like, "Oh, where are we shooting today?" Or "Did you hear what happened on set?" I'm like, "No, I didn't, because I was somewhere else." So
I have
one
a,
of the,
sorry, quick question about
yeah,
that. Um, are you typically given days to go into the rental house and prep and get all your universes set up and take care of all that stuff?
depending on the size of the package, we will have some extra time. Sometimes production doesn't help us with that when POs don't get approved super quickly, and and then you know the rental house gets the PO at the last minute, and then they have to sub rent some stuff. But yeah, we typically have some time in the shop, and I'll have help, and I'll have a rigging programmer there to take the lights and address the lights. Like the first thing we almost always do is factory reset the lights. So you're getting out of the protocol the last person used and changing the channel the last person used. Um, but we spend on Madam Web, for instance, we have a lot of drop packages. I spent a lot of days in the shop on that job. Some sets I never went to. I just sent trucks there. I received trucks coming back. So some of the sets when I saw the movie, I was like, "Oh, that's what that set looked like." I was never actually there. One of the big things, one of the things, the way the rental house can really help is even the people that are filling the orders just need to ask questions and just need to um, think about what they're laying out on the floor sometimes, because my boss might make a mistake or the rental agent might make a mistake. Here I've got an order with 20 sky panels, but there's 20 baby stands. The sky panel doesn't go on a baby stand, but somebody might have done the wrong keystroke on the computer. But if the person in the rental shop sees things like that, and they could ask a question the day before, or just be like, "Well, why is there all this 60 amp cable and all these lights or 100 amp lights?" Asking those questions can definitely save some headaches down the road and some last minute scrambling for sure.
So I'm curious as to what kinds of things give you the greatest satisfaction. When do you have a day that you're like, well, that was good?
Well, you know, we like to have fun at work, so it's nice when people are happy. You know, there's definitely days when some days are hard. Some days you think you're going to do a 10, you end up working 12, you end up in the rain. Like some of those days are rough, but it's nice when everything works. It's nice when you get a text from the best boy electric on set, "Hey, this worked great." Um, or, you know, sometimes you get that text, "Where are the spare bulbs? We had a burnout." Or, "Why is this?" You know, some of those late night texts are can be a bummer, but it's nice to know when everything works and that you rigged the right part of the set with enough power and you put it together and they got their shots.
Yeah. Is there anything that keeps you awake at night?
Well, when they're doing a night shoot, that kind of keeps me awake because you sort of wonder what's happening while you're supposed to be sleeping.
Right.
Because our days can be, some days we'll open the set. So we've rigged it the day before, but the last bits of cable couldn't be run across the street, or you couldn't leave the windows open at a residence. So some days we'll open the set by being there with the shooters to show them where everything is, connect those last dots. Then we'll leave and we'll go wrap the set from the day before, and then we'll drive and rig the set for the next day.
Yeah.
So some days you're in three places, and then sometimes the locations department says, "Oh, the contract expires at 10 o'clock tonight. You have to come back and wrap today's work when they wrap." So then you can be sitting there waiting for them to wrap, and your day can get pretty long. So we can be in a lot of places in the same day, and on a bigger job, those same people aren't in all those places. You just have different crews. You'll have a small group of people at one set, a small group of people at another set. So the one thing I couldn't do my job without is my phone, without being able to text like large groups of people and communicate in that way. I really don't know how we did it before phones and before that level of communication.
Yeah.
Because communication is really what saves you at the end of the day.
I think one of the things that I reflect on is like certain people, sometimes it's just one person, but certain people bring certain special skills, and you may not even realize that they have these skills, but they bring something to the table, and it makes it sort of completes the group that you've got.
Yeah.
Um, so have you worked with technicians or grips sometimes who just brought something special to the table and gave you value?
Well, some guys are really good with power. You know what I mean? Like they're good with the heavy work. Some guys like being on ladders. Some people don't. Some people are really good at soldering. So I mean, a big part of my job is like trying to figure out who's on your team and put them in the right places, and that you don't take the guy that's 6'8" and have him crawl underneath the stage to chase the DMX. And the guy that solders really well, you don't put him on 4/0. You try to keep him on some detailed stuff. So we have a pretty diverse group, and people come from a lot of. Some people had other careers before this, or some people just got pigeonholed into specialties. But it's nice to put people in positions where they're going to succeed. It's better for the project. It's better for my sanity, that you just know that things are being taken care of properly.
Yeah. I guess this was like kind of an old timer question, but do you find that or younger people that understand networks better or not?
Oh, like networking lights and stuff. For sure. Like people can get through menus. People who've been pushing buttons on computers can get through the menus and stuff faster than older folks, including me. Some stuff just gets picked up really quickly. But like the stereotubes have so many different modes, and there's only three buttons. It's not like you're working on a keyboard typically, and some people can just pick that up and they just get through it really quickly. And then sometimes I feel like my mom trying to like troubleshoot the Wi-Fi whenever I can't get it to work. So it definitely helps to have some young people and some older people, and to have a diverse group is always best.
Yeah. Yeah. I wonder if that's like, if I was a young person coming into the industry, sort of like, plastics, like the advice of the older person to the younger person is what you do.
Mm-hmm.
Go into, figure out networks, figure out these lights, figure out all these menus. So what about like, how should people think about safety? Like people coming in, thinking of people in their 20s, we hear about horrible accidents that have happened that never should have happened. And, what would you tell a young member of the crew who is maybe being careless, or just doesn't know?
I mean, just ask questions and pay attention to what other people are doing. And if nobody else is doing, if you're about to do something that you haven't seen anybody else do, you should ask questions about why am I doing that. And then, I mean, I've also had some people who are like on a ladder in a very safe way, and they don't feel safe, and they say this isn't right. And I'm like, well, this is how we always do it. This is how the other 10 people on the crew can do it. If you're not comfortable, we'll put somebody else on the ladder. No hard feelings. You should really only do what you're comfortable with. You know, we wear harnesses now, and we do a lot of things that we didn't do that much when I started in the business. So there's definitely a bigger eye on safety than there ever has been, in my opinion. I'm still sometimes surprised that we don't wear hard hats. Like, I think you could make an argument that we could, anytime there's people working overhead, anytime there's lifts up in the air, if you're on the ground, you should have a hard hat on. But nobody else is doing that. I don't think anybody's just going to start doing it. So probably have to be an accident. There'll probably have to be a reason that becomes normal.
That's exactly right. You know, it's funny because I am involved with the safety training program in Los Angeles, and there's been a lot of discussion at the higher levels. You know, the safety reps at the studios, they all know that we should be wearing hard hats when there's people working above you. Yeah, that's just a standard OSHA rule. It's like, but trying to get people to wear hard hats is really, really hard. And they finally gave up. They just gave up.
Yeah.
Until you're right. Until somebody gets hurt.
I mean, we got through COVID with, you know, I mean, that was a big part of the safety was all the masking protocols and all the rules that were suddenly thrust upon us, and most people followed them to a T because it was just the time, and people were very vigilant about it. But you know, if somebody rolls by in a condor that's not wearing their harness, like, people aren't that vigilant. People aren't really going to look up, and you know, nobody's going to rat them out. But like during COVID, if you walked around with your mask halfway down, you'd have like 5 people yelling at you to pull your mask up. Oh yeah.
Do you think your attitude towards safety has changed since you were in your 20s?
Yeah, for definitely with age, you start to be more cautious, I think. I mean, the first time someone put me up in a condor, it wasn't a harness, it was just a belt. It was a condor belt, which I haven't seen one of those in years. But if I perchance was hanging by that condor belt, there's no doubt that I just would have slipped right out of it. I don't know how that was ever legal.
Yeah.
But at the time, it was just like, you know, you look at your leaders, you look at your bosses, and they're like, yeah, this is what we use. So, okay, that's what we use.
Right.
But yeah, condor harnesses have come a long way. And often the production wants to supply them. Like if I show up with my own harness, sometimes they'll tell me that you can't use your own harness because they haven't inspected it. So lots of times we end up buying new harnesses on every job.
Oh, wow. So looking forward, what do you think the big challenges are for the lighting crew and for the rental industry as we sort of forge forward with the, you know, production as it is?
Well, I mean, you talked about the networking. I mean, so much of it is about being wireless and network and control. And every time a new light comes out, it seems really bright, but the gaffer's always like, well, let's have 5 of them instead of 2 of them. Like, they always want it to be brighter. And some of those rigs that you showed on the picture where there were 16 vortexes, I'm going to tell you that we sent it up and we ran it at about 20%. It didn't need to be 16 vortexes, but that's just what would fit on the lift. So that's what they sent up just in case.
Right.
And a big challenge from the rental house point of view is like keeping the firmwares updated. Like if on those vortex arrays, if 8 of the vortexes are on the most updated firmware, but 4 of them aren't, they're not all going to respond the same way from the console operator. So that's definitely a challenge, is to stay on top of that, to check that, because I mean, some of the rental houses are very busy. They don't always know exactly when the new firmware comes out. Sometimes they're renting lights from multiple companies to fill an order. That's that's been a big challenge. It's been a big thorn in our side lately.
Yeah. Yeah, I think that is a challenge. I think that is a challenge for the rental companies too, but something that, that they could do. Well, I think we're almost out of time here. Just, are there any other questions from the audience?
I've got a quick comment, if I may.
Yeah,
Mike
yeah.
Harwood, I'm the National Rental Technical Director up at Sunbelt Film and TV in Canada. Just comments on the BES as mentioned, Jim, there's jobs that'll work, there's jobs they won't work. We have everything from a 3.6 kilowatt hour to a 3-phase 150 kilowatt hour, which is mounted on a trailer. So depending on your job, the size of the job, people say, oh, use them on the circus, the base camp. We do shows the base camp's bigger than the set lighting because of the introduction of LEDs.
Right.
And as Jim just mentioned, is that light that you're going to do your calculation? Is it going to run for 20% or 80%? Is it going to run for 2 hours or 8 hours? So all I can say is just keep in touch with your equipment supplier and find out how you do your calculations, because they are usually set at kilowatt hours. So obviously
Yep.
the light's going to run for a certain amount of time, and see if it'll work for your job or not. So
Okay.
and the technology is constantly changing.
Yeah, thank you for that. I know that Weiss is one of the first to really invest and get involved in it, and they have some experience with it.
Yeah, we're just trying to supply what our customers are asking for. And again, there's, we can make them, as Jim mentioned, we can make them bigger and bigger, but now you need a flatbed trailer and a forklift to deliver. So as this
Right.
seminar is about its portable power, it gets to the point it's not portable anymore.
Yeah.
Mm-hmm.
So.
All right. Well, good. Well, thanks, Jim. This has been a pleasure.
Yeah, thanks very much for having me. And if people who are looking to make a move to, if you're working in rental and you want to work on set, one of the things I recommend would be picking up Harry's book.
Yeah.
And Harry and I did not discuss this, but I do have my edition of Harry's book is from 1996, long before we met. The blue cover, that might be the first edition, I'm not sure, but there's lots of stuff in there, and it's not like you're going to sit down and read it from cover to cover, but there's just different things like, why didn't this work with voltage, and or how big of a cable do I need for this set? There's lots of good information and lots of stuff to sort of get your feet wet in there, because some people are comfortable asking questions and getting in people's faces, and why are we doing it this way and why are we doing it that way, and some people would rather quietly check the book.
Well, thank you for that. I appreciate it.
I will say that even as a rental house person at a rental house who worked with a lot of cable, distribution and portable power systems, Harry's book was also invaluable to me as a reference resource. So
I'm glad it's helpful. It's gratifying to do something that people that use. But yeah, when we're working on the 6th edition of it now, which is it's just a monumental undertaking, because the evolution, as all the rental companies know, the evolution of equipment has just been
fast.
extremely rapid. Yeah. So in 5 years' time, it's just a whole new environment every time.
Right. It'll be obsolete the day that you print it. You'll have to, start on the next
Do
edition.
7th. Yeah.
I know, it really should be a website, I think, or something.
At this
I don't know.
point.
It should be someone else doing it. Anyway, well, thanks, Allison. Thanks for inviting us to do this.
Thank you, Allison.
Thank you. I appreciate both of you, and thank you everyone for joining us today.